Good morning, class. We are looking at exam 4 review covering chapter 4, application of differentiation, chapter 5, integrals, and 6.1 area between curves. So there's exam 4, chapter 4.7 to 4.9, 5.1, 5.5, and 6.1. So here's the first part we're going to cover, 4.7 to 4.8, section 4.7, optimization problems, 4.8, Newton's method. So let's get started with the sections. First, reminding everyone of differentiation formulas that we have seen before, the basic differentiation formulas, chain rule, product rule, quotient rule, trig functions, inverse trigs, delta y versus dy, a linearization which refers to finding a tangent line. And of course, the definition of the E1 format is the limit of 1 plus 1 over n to the power of n as n approaches infinity, or limit of e to the power of h minus 1 over h as h approaches 0 equals 1. So optimization problem. We want to find two numbers whose sum is 54 and whose product is a maximum, as an example. So we would say you have an objective function. Our objective is to maximize their product, let's say x times y, if the two numbers are x and y. And it's subject to, the constraint is x plus y must be 54. Now, one thing that is important to understand, when we do the first or second derivative test for absolute extrema, a local extremum is an absolute one if it is the one and only one extremum, and it's dealing with an open interval. So if we have an open interval and one critical point, local becomes absolute, because when we do the test of the first or the second derivative test, they just give us local extremum. If 5400 pi inch squared of metal is used to construct a cylindrical storage drum, what is its maximum possible volume? First and foremost, here's the shape. And we want to maximize the volume, pi r squared h, a piece of information from geometry we should have. And it's subject to the constraint. The surface area is the area of the base, pi r squared times 2, so 2 pi r squared. And the surrounding, the lateral surface, if you cut it open, it looks like a rectangle where the width, if you will, would be the circumference, or 2 pi r, and times the height. So 2 pi r h equals 5400 pi. A farmer wants to fence a rectangular field beside a river with a 2400 feet of fencing. The river itself will be one of the four sides. What dimensions will give the largest area? And we come up with the setting. Remember, this is a word problem. You have to come up with the setting. You have to define your variables. You can't just say v equals pi r squared h without showing what is r, what is h. Over here, you want the largest area. You can't say you want to maximize the area x times y without showing which one is x, which one is y. So you want to maximize the area, which is x times y, subject to 2400 feet of fencing. Normally, the parameter is x and x2x, y and y2y. This side doesn't need it, so simply 2x plus y instead of 2x plus 2y equals 2400. Now, as you notice, a is a function of two variables, x and y. We want to make it a function of one variable, so we're going to solve for y. And we're going to put it into the a equals xy, the area. And we get x times 2400 minus 2x. Now, x is between 0 and 1200. The reason being, X is a dimension, must be positive. Also, it must be less than 1200 because if you set this one equal to 0, X becomes 1200. At X equals 1200, the area becomes 0 also. In other words, Y, which is 2400 minus 2X, Y becomes, if X becomes 1200, Y becomes 0. So there is no area. And of course, if you choose it to be larger than 1200, then this becomes negative, area becomes negative. That's why here's your domain, which is an open interval of 0 to infinity. You differentiate this by distributing first. First, A is 2400x minus 2x squared. Differentiation will result in A prime of x being 2400 minus 4x. Because we want to find the CP, we set this equal to 0 and x becomes 600. We have an open interval with one critical point, and this concept that whether we do the first or second derivative test, it goes from local to absolute. So it's easier to do a double prime, the second derivative test, which is negative 4. Negative 4 is that we are interested in the sign. It makes it concave down, looking like that. So the maximum occurs at that point. Remember, you have to evaluate a double prime at the CP, but it is independent of x. Then whether it's x equals 600 or no matter what, it will always be negative. So the maximum occurs when x is 600. So you put it into this or this one to find y, and y becomes 1200. So the dimensions are 600 by 1200, and the maximum area is 720,000 square feet. So this is the process that you are going to use to find the largest area. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions that minimizes the amount of material used. So first, reminding everyone, this is called a rectangular solid or prism. The volume is the width times the length times the height. Surface area, we have the bottom, length times the width times 2 because the bottom and the top are the same. And we have 4 walls. The front one, for example, is the length times the height, so is the back one. And the sides are the same, the width times the height. That's why we have 2 times W times L plus H times L plus H times W. That's surface area. That means the concept of gift wrapping. If you have a cube, all sides are identical. The volume becomes S cubed. One side has a surface of S squared. There are 6 of them, so 6S squared. And so what's happening here, what is it that we want to achieve in this example? We want to find the dimension that minimizes the amount of material used. So gift wrapping, in essence. So first, let's look at this being X and this being H. Let me just write it. Then what happens is the base is X, this is also X, and the bottom has area equal to X squared. There are 2 of them. We should have 2x squared, but it's open top. It's only x squared. Then this wall is the x times h. And because the base is a square shape, they all are equal. So there are 4 walls, each one x times h, 4xh. Subject to the volume of 32,000. The volume is the area of the base x squared times the height. So the volume x squared h must be 32,000. Now we are in business. We are going to solve for h and put it into s, because s is a function of two variables, x and h. So if I solve for h, that means 32,000 over x squared. I can replace the h in the surface area. And notice the very first thing, instead of s, I'm going to say s of x, because this is s of x and h. So 4x times h, 32,000 over x squared plus x squared. 4 times 32,000 is 128,000. This x cancels out the exponent here. And we get 128,000 over x plus x squared. Because we want to differentiate this, we are going to rewrite it as 128,000 x to the power minus 1 plus x squared. And so what is s prime is the product of these two numbers, making it negative 128,000 x to the power minus 2 plus 2x. And x must be positive. The reason x must be positive, class, because x represents dimension. So let's write an open interval of 0 to infinity. In order to find critical points, we want to write this in a manner that is doable. So we are going to get rid of this, put it down here, take a common denominator of x squared. This doesn't change, but this one becomes 2x cubed. Now s prime equals 0. You put the top equal to 0 and you solve. S prime does not exist. We are looking for critical points. You set the denominator equal to 0. X becomes 0. It's not part of the domain, so that doesn't work. Let's set the numerator equal to 0. Move. The negative becomes positive 128,000. Divide by 2, you get 64,000. Take a cube root, you get 40. And as always, you have to write the units, 40 centimeters. Let's do either the first or the second derivative test. The second derivative test is easier. S double prime we go back here. We go back here. S double prime is the product of these two numbers, which makes it positive 256,000 x to the power of negative 3 plus 2. The second derivative test says plug in 40 and observe, and all you have to know whether it's positive or negative. That's all. You're not interested in anything else. You just want to know it's positive or negative. And notice this is 256,000 divided by x cubed or 40 cubed. You don't even have to evaluate this. This is a positive value. Plus 2 is positive. In fact, it ends up being 6. Okay. And it's concave up. So it gives us the minimum. Yeah, 40 cubed is 64,000. And when you divide it, you get 4 and 2 is 6. So concave up, the minimum occurs when x is 40. So what is the height? You can use this one or this one and say 32,000 divided by 4d squared. 32,000 divided by 1600, h becomes 20 centimeters. So you're going to write h is 20, x is 40. We are done with this because they were asking for the dimensions. If they ask what is the minimum amount of material into this formula, we replace the x with 40, h with 20, which ends up being 4 times 40 times 20, 4 times 40 times 20, plus 40 squared equals 4,800 square centimeters. That's the amount of material. What is the minimum distance between the two parabolas? One is y equals x squared plus 1. One is y equals x minus x squared. We're going to graph both. I'm going to assume nobody has any problem with graphing. Of course, this is y equals x squared shifted up by 1. And this one you can find the vertex starting with x equals minus b over 2a, plug in, find the y coordinate, and it, because this is negative, it opens down. And now we want to find a minimum distance. So let's get 2 points we don't know anything about. This one is on the top function. This is on the bottom function. So this has coordinates x, and the y is x squared plus 1. This one has coordinates x, and the y coordinate would be x minus x squared. And we want a distance between the two. It's a vertical distance. That's why we're going to call it v of x, and simply put, when they have equal x coordinates, just the difference between the two y coordinates would be the vertical distance of the top x squared plus 1 minus the bottom x minus x squared. Now, x can be anywhere. We just eyeball it and say it looks like it's here, but it could be anywhere. Could be maybe somewhere here. I'm just making things up, meaning what could x be? Anything. X can be any number between negative to positive infinity. Let's simplify this as follows. We're going to combine these two, and we get 2x squared. We put it in descending order, 2x squared minus x plus 1. And as I said, x is between negative and positive infinity. We are going to find critical points by finding v prime 4x minus 1 and setting it equal to 0. Clearly, x becomes 1/4. Now, we have an open interval with one critical point. So whether we do the first or second derivative test, local becomes absolute, meaning we have to test this. We're going to go with the second derivative test is easier. V double prime is simply positive 4. Positive means concave up, and concave up makes it minimum. And by the way, when V double prime is a number, V double prime, when x is 1/4 or any other number is the same thing. Whether you mention that or not is not important, as long as you understand. When a function is independent of x, it's always the same. So v double prime at any number is always 4. And that means the function is always concave up. And concave up looking like that gives us the minimum. So the minimum occurs when x is 1/4. What is the minimum distance? You have to plug into the v function. Absolute minimum is v of 1/4. So let's plug in and we can plug it into this or the simplified version of it. Plug it into this 2 times 1/4 squared minus 1/4 plus 1. This is 1 over 16 times 2 makes this 1 over 8 minus 1/4 or minus 2 over 8 makes it minus 1 over 8 and 1 becomes 7 over 8. So the absolute minimum is 7. By the way, if you want the exact coordinates, you put x equals 1/4 here, you find the y coordinate for this point. You put it in here, x minus x squared, you find the y coordinate for this point. Okay. A cylinder is inscribed in a cone with height h and base radius r. Find the largest possible volume of such a cylinder. So here's a cone with a fixed height and radius, and here's some cylindrical shape that is inscribed in there. So let's define our variables. This is the height, which is fixed for the cone. This is the radius, which is again fixed for the cone. And if we call this distance x, which is the radius for the cylindrical shape, and the distance from here to the top is, we call it y. Remember that this cylindrical shape has a radius here, let's say capital R, and the red one is the height. So the volume is pi r squared h. Again, a piece of information from geometry we should have. Now, r, the radius is the same as x. The height is the height of the cone, h, minus this distance of y. So instead of capital R, we're going to go with x, and instead of capital H, we're going to go h minus y. And notice the volume becomes a function of two variables, a, x, and y. We want it to become a function of one variable. So we want to find a relationship between x and y. First of all, notice this half looks like a triangular shape. We are dealing with similar figures where the small triangle and the large one, the entire one, are similar figures, meaning their corresponding angles are identical. Notice this is common in both. This is 90 degrees, this is 90 degrees, and this is also equal to this one because these two lines are parallel. Or you can say if two are equal, the third one is 180 minus the sum of the two. And therefore, corresponding sides are in proportion. So if you look at the small one, you say, I'm going to pick x from the small and r from the big one. So x to r. Then I'm going to pick y from the small one. Corresponding to that would be h from the large one. We get x over r equals y over h. Now this gives us a chance to solve for one of those variables. We're going to solve for y, which becomes h times x divided by r. And now if we replace it, the volume becomes a function of only x. So we're going to write v is pi x squared times h minus, replace the y, everybody. And now this is pi x squared h, or h x squared. And when we multiply these two, we get pi h over r x cubed. The reason we write it in this fashion, please understand, pi and h are just constant, pi is a number, and h is not changing, is fixed. That's why pi h r is also fixed. So we want to write it in this format so it becomes easy to go to the next step, which is differentiation. Now the question is, what about x, and why is x between 0 and r? First and foremost, x represents the radius of the cylindrical shape. If it's 0, first of all, dimensions can't be negative. If it's 0, there is no cylindrical shape. If it's r, as large as the radius of a cone, there is no cone. So it has to be between the two values. Now we are going to differentiate v prime of x. This is pi h times 2x, or 2 pi h x. This one remains, and then times 3x squared. So minus pi h over r times 3x squared. So this is 2 pi hx. This is minus 3 pi h over r times x squared. We notice pi is in common, h is in common. We can also factor the x, which is in common. So if I take the pi hx out, this gives me 2. This gives me minus 3 over r, and one of those x's remains, so minus 3x over r. We set this equal to 0, and either this one is 0, that means x is 0, or this one is 0, that means x is 2/3 r. So I want to make sure we understand what happens here. Either this one is 0, or 2 minus 3x over r is 0. That means 2 is 3 halves x, and so x is 3 over r, I meant. And that means x is 2 times r divided by 3, or 2/3 r. Can x, the radius of a cylinder, be 0? No, that is out. So there's only one possibility. We have an open interval of 0 to r. Remember, r is a positive number. We have one critical point, so it's going to be not only local, also absolute. Now, is this going to maximize or minimize the volume? We don't know yet. We have to do the first or second derivative test. We are going to do the second derivative test using this one, v prime. We are going to differentiate it again. So this becomes 2 pi h. This is minus 3 pi h over r. A number remains, times 2x. So this is 2 pi h. And then when we multiply this one by 2x, we get 6 pi h over r minus 6 pi h over r x. And we have to evaluate this when we have 2/3 r to see if it's positive or negative. That's the second derivative test. Plug in, evaluate the second derivative at the critical point, and pay attention just to the sign, either positive or negative. So we plug in, we get 2 pi h minus 6 pi h over r times 2/3 r. So what you have is 2 pi h minus 4 pi h, or minus 2 pi h. Now, how do we know minus 2 pi h is negative? Pi is a positive value, h is positive, and therefore negative 2 makes it negative. Negative means concave down, means maximum occurs when x equals 2/3 r. So what makes this the maximum volume of a cylindrical shape when x is chosen to be 2/3 r? What is the maximum volume? We're going to plug it back into this formula, this formula, this formula, you name it. So if we go with this formula and we just replace the x, if we go with this one, it's easier at that. So replace the x with 2x equals 2/3 r. So pi h x squared minus pi h over r times x cubed. It's pi h x squared times 1 minus x over r. And you replace the x with 2/3 r, this x as well as this x. So this is 2/3 r quantity squared, and this is 1 minus x. 2/3 r divided by r is 1 minus 2/3, and I hope you recognize this as 1/3. So 1/3, this is 2/3 squared, or 4/9. 1/3 times 4/9 is 4/27 pi r squared h. I hope you can see that the product of this becomes 4/27 pi r squared h. Bear in mind, r, lowercase r, h, lowercase h, those are fixed numbers, and so is pi, whatever r and h are. But pi, of course, is not missing. It's an irrational. (4.8) Newton's method. Consider a function as it crosses the x-axis, which is known also as the x-intercept or the root of the function. So here's a function. It crosses here, here, here. Newton noticed that tangent line close to the root crosses the x-axis nearby. So here's one of the roots. So a tangent line, not necessarily at that point, nearby, crosses the x-axis here. Is this the root for the function? No, but it's close. That's the concept. So we are going to use the good old point slope, y minus y1 equals m times x minus x of 1. And if this point, the point of tangency, we call it x of 1, we can find the equation of a tangent line as y minus f of x of 1, right, minus y1 equals m, which is f prime of x of 1 times x minus x of 1. That's the equation of a tangent line. Of course, you have to move this to the right, simplify all of the above. But this is not what we want to do. We want to look at the next step, and that would be, what is the y-intercept for this tangent line somewhere here? The y-intercept by definition, the x-intercept by definition is this point. You set y equal to 0. So if you set y equal to 0 here, so replace this one with 0. So we have 0 minus f of x of 1 divided by f prime of x of 1 gives us the parenthesis x minus x of 1. And so x is this plus that, or x of 1 minus f of x of 1 over f prime of x of 1. So in essence, what we have This is the point of tangency. We draw a tangent line. It crosses the x-axis at some point. This is the x-intercept for the tangent line. We use this process to find that point. Use that point as a second and usually a better estimate for the root of the function. So in other words, this is sort of closer to this than this one, if you look at this one. So we are not getting to the root yet, but it's slightly better. And then what happens? Now we're going to use this point and use a tangent line. So now this will give us x sub 2 equals x sub 1 minus f of x sub 1 over f prime of x sub 1. We're going to go through the same process here. So we keep on getting closer and closer through this process. X sub 3 would be x sub 2 minus f of x sub 2 over f prime of x sub 2. And in general, repeated application of this process is called Newton's method. And f of x sub 1 is f of x sub n minus f of x sub n over f prime of x sub n. Please understand, all of it comes from the good old point slope and finding the equation of a tangent line and setting y equal to 0. That's the idea at each step. So this is the idea. Now, to recap, consider a function as it crosses the x-axis, which is called the root or the x-intercept. Need to notice that tangent line close to the root crosses the x-axis nearby. Tangent line intersection has this one. Okay, x sub n plus 1 is x sub n minus f of x sub n over f prime of x sub n. Okay, so here's the graph or the curve. Some point x sub n. You draw a tangent line. This is what you're looking for. The root of the function. This is what it gives you, which is not root of the function, but it's close. That's the idea. So y equals f of x. At some point, starting point x sub 0. So x sub 0 is far away from the actual root, but we can start with that. If we draw a tangent line, the blue line crosses the x-axis at x sub 1. This is not the root for the red function, but it's getting better than x sub 0. It's getting closer to that. Now, at this point, x sub 1, you draw a tangent line on the curve with the x coordinate being x sub 1. And now the green line, which is the tangent at x sub 1, gives us a root x sub 2. Again, this is not the root, the red one, for the function, but it's getting better. And that's the process that we are talking about here. So you start with that. Again, another graph would be interesting to see. And then as it crosses x sub 1, x sub 2, x sub 3, and ultimately things get better and we get closer and closer to the actual root. Now, when we do this, you may use a calculator as long as you can show work for the first and second. If they're asking for a couple of them, you don't have to use a calculator. But if they ask for more, then it becomes very tedious. So the calculator can be programmed as follows. You set y sub 1 equals f of x, y sub 2 equals f prime of x. And whatever your first choice is, let's call it x sub 1, you store it. This arrow means store. Store it in x. And then x minus y sub 1 over y sub 2, because y sub 1 is your function, y sub 2 is the derivative of your function. So y sub 1 over y sub 2 represents this fraction. You store it in x again. If you enter repeatedly, you get the numbers. Okay. It works out as long as we get better. However, if we end up with a situation where f prime is close to 0, that means if you have a horizontal tangent line or a tangent line which is close to horizontal, then this process fails. Okay, everybody, you have to use a different x sub 1 if you will. All right, let's do this. Calculate 3 iterations of Newton's method to approximate a zero of this function. F of x is x squared minus 2. Use x sub 1 equals 1. Sometimes they give you that, sometimes they don't. You have to choose accordingly. So the bottom line is f of x is x squared minus 1. You need to calculate f prime of x according to this formula. We need the derivative, which is simply 2x. So if you look at the graph, remember y equals x squared is a parabola that goes here, and then x squared minus 2 is the same function moving down by 2 units. Now, x sub 1 is here, x sub 1 equals 1. So you notice means this point on the function, and this is the point that you are going to deal with its tangent line, and it crosses the x-axis at this point, which is not the root of the function, but it is getting closer. That's the idea. This is fairly close to the actual 0 or the root. So with that being the case, we have x sub 1 equals 1. We're going to go with this and find x sub 2, which is this point, and x sub 2 is x sub 1 minus f of x sub 1 over f prime of x sub 1. We're going to replace x sub 1 with number 1. So that means 1 minus f of 1 over f prime of 1. So again, you have to have your function. You have to have f prime. You have to show this one, 1 minus f of 1 over f prime of 1. Now, what is f of 1? If I put 1 in here, I get 1 squared, which is 1 minus 2. So it becomes negative 1. If I put the 1 here, I get 2. So I get 1 minus negative 1 over 2, or 1 plus 1 half, or 1.5. It's very simple to calculate. Be sure the details. So x sub 2 is 1.5, or 3 halves. So this point on the graph of the function has x coordinate equal to 1.5. And now we do a different tangent line, the green one. As you can see, that's even closer to the actual root. The green line is the next tangent line, and it's closer. And according to this formula, now we're going to say x sub 3 equals x sub 2 minus f of x sub 2 over f prime of x sub 2. So x sub 2 is 1.5. So 1.5 minus f of 1.5 over f prime of 1.5. So over here, you put 1.5, square it, you get 2.25 minus 2 becomes 0.25. Over here, you put 1.5, 2 times that makes it 3. So we have 1.5 minus 0.25 divided by 3. And it ends up with, if you use a decimal, 1.416667. However many decimals they ask you. Normally, they ask for many decimals. I want you to know that. So they want 3. We're going to do 1 more because they gave us 1. This doesn't count. So we have to go with x sub 4. According to this formula, x sub 4 is x sub 3 minus f of x sub 3 over f prime of x sub 3. And this is what I mean. Right now, you have to replace x sub 3 in this formula with this number. And trust me, it becomes now a little bit more difficult to go here. You have to calculate this, you'd use a calculator, you plug in, and you end up with this number, 1.414216. So as far as, again, the number of decimals, you have to pay attention to what they ask you. If they don't, you want to put a lot of decimals. This wasn't too bad because we had to do only 3, okay? But understand the third one was a little bit more tedious. Use Newton's method to approximate the 8th root of 500 to 8 decimals. Again, I'm writing x7 plus 1 is x7 minus f of x7 over f prime of x7. We want to use the Newton's method. There are different methods you can use. We have used differentials, linearizations before. And I'm writing this because when the numbers get involved, you can use this little programming. So first and foremost, what is this? Let's call it x. So if I raise both sides to the power of 8, I get x to the power of 8 equals 500. So if I bring the 500 to the left, it becomes x to the power of 8 minus 500 is 0. So the function is x to the power of 8 minus 500. Why am I coming up with the function? Because if I come up with this root or 0 or x-intercept for this function is the same as the 8th root of 500. Please understand the concept. So then we need f prime, which makes it 8 x to the power of 7. And we're going to write this x7 plus 1 is x7 minus f of x7, which is this function, x to the power of 8 minus 500, over f prime, which is this function, 8x to the power of 7. Now, where do we begin? You may know that the 8th root of 256 is 2, the 8th root of 6561 is 3. So even if you did not know the answer, you would sort of guesstimate that it's probably close to one of those numbers. So it doesn't matter which one you use. Any of them you use will come up with the same answer, because as long as you can show work for the first couple of steps, then you use a calculator. So let's start with this one as x sub 1, everybody. So start with x sub 1 equals 2, continue until they agree to 8 decimal places, why 8? Because they said so. So we're going to write x sub 2 is x sub 1 minus x sub 1 to the power of 8 minus 500 over 8 x sub 1 to the power of 7. So this is going to be 2, this is going to be 2, this is going to be 2. So 2 minus fraction bar, at the top is 2 to the power of 8 minus 500, at the bottom is 8 times 2 to the power of 7. And this numerator becomes negative 244, this becomes 1024, this becomes positive, and we write a bunch of decimals. Now, clearly, if I want to go with x sub 3, I should write x sub 3 is x sub 2 minus f of x sub 2 over f prime of x sub 2. And this is a crazy number, and that would be a good time to use a calculator. So into y sub 1, you put f of x equals x to the power of 8 minus 500, and y sub 2 equals f prime of x, which is 8x to the power of 7. And if you 2 stores in x, if you click on that, and then x minus y1 over y sub 2 stored in x, it gives you this number. And all you have to do, press enter, enter, enter. And you keep on entering. Now, notice we have to come up with 8 decimals. So we have to look at where 8 decimals agree. For example, here and here doesn't work. But if you look at these last 2 that I have, take a look at this one. See, 1, 2, 3, 4, 5, 6, 7, 8, 27 would be 7th and 8th. And if you look at this one, they are identical. In fact, even the next one is identical. okay? So, whereas the previous one up to 2 is fine. So, with 8 decimal places, we're going to go with 1, 7, 4, 5, 5, 9, 2, 7. Because next to 7 is 6, we take it 1 notch up and we change it to 8. And we say the 8th root of 500 is 2.17455928. So for a question like this, you must show f of x, you must show f prime, you must show the general solution, and you must show at the very least x sub 2 and the answer to that, and then you can use a calculator. So for the next exam, you can use a graphing calculator for that if you like. So y1, we're going to put f of x, which is x to the power of 8, x to the power of 8 minus 500. We enter that. F prime is 8, x to the power of 7. We are going to start with number 2 and STO, store it in x, press enter, x minus, I want to go with y1, so variables, y1 divided by variables again to the right, functions, and now bring it down to y sub 2. So y1 divided by y sub 2, and we are going to store it again in x, and it gives us the first number, 2.238282125, as we had it here. And if you press it repeatedly, it gives you the numbers that we were looking for. So I wanted to show you how the calculator thing works in case. This is to speed up your process and make life easy in case, because some of them may take long. Use Newton's method to approximate the positive root of 3 sine x equals x to 6 decimal places. Here's a rough sketch. The line y equals x, you can graph it. The function y equals 3 sine x, you can graph it. And points of intersection are of interest to us. So this is one way to do it. Graph 2 functions. One is the left side, one is the right side. And we are interested in finding this one, because we want the positive root. This is positive, this is negative, this is obviously 0. And so the function, of course, will be just bring them to the same side. Doesn't matter to the right or left. So either x minus 3 sine x or 3 sine x minus x makes no difference. The derivative f prime would be 3 cosine x minus 1. And therefore, this becomes x sub n plus 1 is x sub n minus f of x sub n. That means minus 3 sine, you put this 3 sine x minus x in the numerator. F prime, you put 3 cosine x minus 1 in the denominator. And x sub 2 would be x sub 1. So change this to 2, change this to 1. Now, we choose x sub 1 to be 2. Why is that? As you can see, this 2 seems to be pretty close to that. You can go with 2, you can go with 3, you know. So if you plug in 2, so replace this number with 2, this number with 2, this number with 2, this number with 2, and now you have to use a calculator. So when x sub 1 is 2, x sub 2 using a calculator is this one. And remember, you want 6 decimals. Now, at this point, again, it becomes very tedious if you do it by hand. So we are going to do it with technology again. So y sub 1 is f of x, 3 sine x minus x. Y sub 2 is f prime of x, 3 cosine x minus 1. We store the first one, x sub 1 equals 2 into x, and then x minus y sub 1 over y sub 2 is stored in x. It gives us some numbers. And remember, we want the 6 decimals just for the sake of argument. You see, they are not the same. So you have to do again. Okay. And notice, so we count 1, 2, 3, 4, 5. The sixth one is 2, 1, 2, 3, 4, 5. The sixth one is 2. So they are identical up to here. We want it to be up to 6 decimals. So we stop here, and both of them, this one to the right is 6, this one to the right is 8. It goes up to 3 when we want to report that. So take a look, 2.27886. 2 changes to 3 because next to it is a number larger than 5, as long as the number is 5 or larger. So you want to be very careful with your rounding. So you're going to say the answer is x sub 4, 2.2788663, which is almost the same as x sub 5. And we're done with that.